Here we move to the next level of abstraction, blocks. Block modules are built on top of layers. Essentially, chaining a sequence of layers gives you a block. You could either create your own customized blocks and add them to your library, or use the built-in blocks that we offer. In order to create your own customized blocks, you need to rely on block construct. The block construct comes with 4 parameters: layers, residual layers, post layers, and aggregator. Layers parameter specifies the chain of layers forming the main branch of the block, whereas residual layers parameter specifies the chain of layers forming the residual branch of the block. Aggregator operator determines the operation used to aggregate the final outputs of the main branch and the residual branch of the block. Post layers parameter specifies the sequence of layers being applied to the output of the aggregator. In addition to the block construct that allows you to create your own customized blocks, we also offer a number of built-in blocks. Built-in blocks are point-wise feed-forward block using transformers, as well as residual block and bottleneck residual block. Using built-in blocks, you don't need to manually design them, and instead the platform creates them for you. For example, in the case of built-in residual block, we surface all the parameters that are required to specify its exact architecture and configuration. These parameters include the channel sizes for the input and output feature maps, as well as the kernel size, stride size, and the activation. We provide 2 interfaces to design modules, the config interface and the graph interface. Right now what you are seeing is the config interface. You can switch to the graph interface by clicking on the graph button. Switching between these 2 interfaces is a seamless experience, and any changes that you make in one interface will be transferred to the other interface. In most cases, designing a module requires switching back and forth between these 2 interfaces to finish the design. When users switch between these 2 interfaces, we validate the parameter values and the design. For example, in the case of this residual block, clicking on the graph button, the system complains that we haven't set the value for the channel size of the output feature map. Setting the channel sizes for the input and output feature maps, this time we can successfully switch to the graph interface. Now we are in the graph interface, and we see the graph representation of the residual block. The main branch consists of 3 layers, 2 convolutional layers and 1 ReLU layer, whereas the residual branch has a single convolutional layer. The outputs of the main branch and the residual branch are being aggregated using an addition layer. The output of the addition layer is being passed to the ReLU layer, which is the only post-processing layer. You can inspect and modify the parameters of each layer node by clicking on the setting button with the gear icon. We switch back to the config interface by clicking on the config button. Next, we inspect the underlying graph of the bottleneck residual block. Finally, we check out the architecture of the point-wise feed-forward block. Now we want to design a brand new block without relying on the built-in blocks. In order to do so, we start by adding a new layer to layers parameter. From the top-down menu, we have access to all the different layer types that we could choose from. In addition to the default layer types, we have access to the customized layers in our personal library. Here we choose demo linear from our personal library. As you expect, the input size is 16 and the output size is 32. We click on checkmark buttons in order to save the changes that we have made so far. We click on Save As button to add this customized block to our personal library. We choose Demo block as the name for this customized block. Demo block is being successfully added to our personal library under User Blocks. Switching to the graph interface, we observe that our block has a single layer, which is the demo linear. We have access to demo linear under user layers in the case if we want to add another instance of it to our block. This time we add a default linear layer by dragging it from left sidebar and dropping it on canvas. Next, we set the values for the input size and output size of this new linear layer. We connect demo linear layer to this new linear layer so that the first layer in our main branch is demo linear layer and the second layer is this new linear layer. We save our changes and switch to config interface. We see that the layers parameters now has two layers and the changes that we made in the graph interface successfully transferred to the config interface. We switch to the graph interface and add a linear layer as part of our residual branch. We set the input size to 16 and the output size to 64 for this linear layer. When you have the residual branch, it is mandatory to have an aggregator layer that takes inputs from both the main branch and the residual branch. We just added a linear layer as the aggregator layer. However, a linear layer is not an aggregator layer, therefore we expect the system to give us an error message. Clicking on the config button, the system validates the block and finds out that a linear layer is being used as the aggregator layer, and therefore it gives us an error message. Next, we replace the linear layer by an addition layer as the aggregator layer. Switching to the config interface, this time we don't get any error message from the system. We see that both residual layers parameters and aggregator parameter are being set correctly. We set the post-processing layer to be a linear layer with the input size 64 and the output size of 128. We switch to the graph interface and add a ReLU activation layer as the next post-processing layer. ReLU layer is being added successfully as a post-processing layer.